Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back to Physics Mathematics Hub, where we make physics and mathematics easy. Today we are going to solve the 7th numerical question from Unit 10 Simple Harmonic Motion and Waves, 10 class physics KP textbook. So let's start. Here is the problem. A station broadcasts an AM radio wave whose frequency is 1230 times 10 to the power 3 Hertz on the dial, and an FM radio wave whose frequency is 91.9 times 10 to the power 6 Hertz on the dial. Find the distance between adjacent crests in each wave. Before going into the solution, we have to know that what is AM radio wave and what is FM radio wave. AM stands for amplitude modulation. In AM radio wave, the strength amplitude of the wave is varied to encode information while the frequency remains constant. FM stands for frequency modulation. In FM radio wave, the frequency of the wave is varied to encode information while the amplitude remains constant. Now let us start solving part 1. We are given that frequency of AM radio wave, which is denoted by F1, is equal to 1230 times 10 to the power 3 Hertz. Frequency of FM radio wave, denoted by F2, is equal to 91.9 times 10 to the power 6 Hertz, and speed is equal to 3 multiplied by 10 to the power 8 meter per second. We have to find the distance between adjacent crests, called the wavelength for AM wave, which is lambda 1, and FM wave, denoted by lambda 2. Let's recall the formula that connects frequency and wavelength, which is known as universal wave equation or universal wave formula. The formula is simple. C is equal to F lambda. For AM wave, replace lambda by lambda 1 and F by F1 and arrange it for lambda 1. We get lambda 1 is equal to C over F1, where lambda 1 is the wavelength we are trying to find. C is the speed of light, which is 3 multiplied by 10 to the power 8, which is actually the speed of the electromagnetic waves, and F1 is the frequency of the AM wave. Plugging the values, we get lambda 1 is equal to 3 multiplied by 10 to the power 8 meter per second divided by 1230 multiplied by 10 to the power 3 per second, which is actually hertz. Dividing 3 by 1230, we get 0.00244, and shifting 10 to the power 3 to the numerator, we get 10 to the power minus 3 meter, cancelling per second with per second. After doing the calculation, we get lambda 1 is equal to 0.00244 times 10 to the power 5 meters. Finally, we get lambda is equal to 244 meters. So the distance between adjacent crests in the AM wave is approximately 244 meters. Now let us find the wavelength for the FM wave using the same formula. Lambda 2 is equal to C divided by F2. Plugging the values, we get lambda 2 is equal to 3 times 10 to the power 8 meter per second divided by 91.9 multiplied by 10 to the power 6 per second. After doing the calculation, we get lambda 2 is equal to 0.0326 multiplied by 10 to the power 2 meters. Finally, we get lambda 2 is equal to 3.26 meters. Therefore, the FM wave has crests that are about 3.26 meters apart. Conclusion: AM and FM radio waves are both electromagnetic waves, but they behave differently due to the length of their wavelengths. AM waves with a longer wavelength can travel further because they can bend around buildings and mountains. This makes AM waves great for broadcasting over long distances. On the other hand, FM waves have much shorter wavelengths, which allow FM signal to carry more information, leading to higher sound quality. So, FM radio generally sounds clearer and better than AM. If you enjoyed the solution along with simple explanation, don't forget to like, subscribe and hit the bell icon so you never miss the problem's solution. Also, feel free to leave any questions and suggestions in the comments below. Until next time, keep learning. Allah Hafiz.